Hi, so I'm gonna do educational round 130 today, and I guess it's been 10 minutes already. So, like, let's get right into it. And I'll probably do only 4 or 5 of these questions because, like, after 1 hour, I have to go for dinner. So probably like 9, 10 or something. After that, I'll just go. Okay. I wanted this to open in a new tab. Right. So, like, I hope I'm recording this correctly. I remember in one contest I was recording, and then there was some issue with, I don't know how I recorded or something, and because of that there was no audio. Hello, hello. Yeah, this time there's audio. So yeah, so that entire video basically got wasted. I don't want that to happen today. Yeah. So the first problem is Parkway Walk. Okay, you are given walking. Mm-hmm. Okay, you have m units of energy to walk 1 meter distance. You need 1 unit of your energy, and you need energy to walk. And you can restore energy by sitting on benches. Okay, okay. Mm-hmm. What is the minimum amount of energy we need to restore? So I guess we just need the total. Okay. Mm-hmm. I guess the total energy spent is just the sum of all these numbers, and then out of this m you are already having, so whatever extra is required, that's the answer. Yep. Okay. Let's see if this works. Probably should. Okay. What? Okay, x minus n actually. Yeah, works. Right. So we have n and m. We add all the numbers in the input, and then the answer is the max of 0 and x minus m, because x is the total energy that we need and m is the energy that we already have. If we have more energy than we need, so the answer is 0 otherwise. This, and I've written 0 ll because I'm doing everything in long long. You can get by without doing that. Okay, works. Second problem is promo. The store sells n items and the price of the ith item is pi. The store management it's going to hold a promotion. If a customer purchases x items, y cheapest of them are free. Okay. Okay. Has not decided on the exact values of x and y. They ask you to process q queries for the given values. Determine the maximum total value of items received for free if the customer makes one purchase. Okay, for given value of x and y. Right. So obviously this total value will be maximum if the customer buys the costliest items. So like if x is 5 and y is 4, so you have to buy like the costliest item in the shop, and then Apart from that, the next four will be free for you. So I guess that's what we have to do here. And it's just a sorting problem then. Okay, this is my code. We have test cases, I guess. Do we have test cases? We don't have test cases. Okay, we have n and q, and it's the number of whatever number of the items in the shop, and q is the number of queries. Then we have p. Okay, so what we will do is we will sort p, and let's do it in reverse order because we care more about the greater values. Okay, so then if the promotion is like x and y, so that means I will just definitely go for the x of the costliest items. But then out of those, x minus y I have to pay for those, but the remaining will I will get them for free. So yeah. And to like quickly get these values, I need to have some kind of prefix sum. Let's call it pf. Okay, and then okay, so this is just the prefix sum, and then now I can get any of these like values very easily. Maybe I can just, yeah, x can be equal to y, right? Okay, so yes, this is my prefix sum, and then for each query I can just go like I can take x and y as input. Okay, so what is the total cost of the x items? So that will be prefix sum of x, but out of these I have to actually pay for x minus y, and the remaining I don't have to pay for them. So we can say the answer is just pf of x minus pf of x minus y, because these x minus y items I have to pay for, and the remaining items are free for me. So that's the answer, I guess. Okay, 856 works. Probably will work. Let's go to the third problem. So these days, educational contests have become like a bit more confusing, I guess. I was a few days ago, I was looking at some educational problem, and then I guess I got stuck at like not stuck, but I got confused at C or B, I guess, for a minute. No, not for a minute, like 5 or 10 minutes. I got confused at that. Like, what do we exactly have to do, and how will we do it? Something like that. I got confused with that, and that's pretty weird because like usually I'm always able to do like F and G from educational, and then like sometimes I'm not able to do G, but at least till F I'm always able to do that. And getting stuck at like C was like, yeah, it was pretty weird. Okay, you got accepted here. So now we have the problem C, Abu's favorite problem, and Abu is basically Pick Mike who makes these contests. So this is his favorite problem. So let's see what this is about. Okay, yeah, 62 people have done it by now, and I think that's too less. Like in the first 18 minutes, only 62 people have done it. That's weird, but yeah, let's go with it. So in one move you can perform. We have two strings and both of them have only A, B, or C. And then in one move we can replace AB with BA and BC with CB. Okay. Can you make S equal to C? Okay. So the way I see it, we can actually, okay, AB with BA, but not BA with AB. Okay. Yeah. Mm-hmm. Like a B that's before a C, it can go further, but then a B that's after a A can go to the left, and before a C can go towards the right. I think I have flipped my camera, so it will be opposite. Whatever. Um. Okay. Let me see what this is about. So if we have like A, B, C, right? So I guess this B can either go here or it can go here, right? But if we had C, B, A, then this B is stuck here and it can't go anywhere else. Okay. Okay. So, and also if we have like a lot of A's, and then this can go all the way here. Okay. But then, and also if we had like a lot of C's, it can go all the way here. Moreover, if we have like CBC, then obviously it can't go here because CB can't be swapped into BC, and C is not involved anywhere. But this B can definitely go here as far as far as it can go. And where will it stop? Either it will stop at the end of the string, or at another B, or at another A, because after that it has to stop. So yeah, I guess we can perform some kind of mm, okay. And if we have like a lot of so if we have like a lot of C's and then there's a B here, okay. If we had some more B's over here, then all of them can go across these C's. But if we had like either this would be the start of the string, or we would have another C, or we would have a A. And I guess if we have a C, then it's obviously like it's obvious that it's always best to okay, wait a second. We can do all this only in S. So T is like we cannot change T, we can only change S. Okay, right. So that gives us some more hint. What we can do is maybe we can try to match the characters of T with S, right? So let's first try to match the first character of T. Okay. Now, if this is like A, then definitely in S also we need to have an A here, because there's no move that will bring A to the left. Okay, so we must have an A here, otherwise it's wrong. Otherwise, we will just say no. Okay, and then once we get this A correctly, then just forget this and work with this remaining string. Okay, again, if we have A, then just do it. What about if we have like a B here? So if we have a B here, then there's a chance that uh, so if we have a B here, maybe we might match it with a B that is already here, so that is fine. Or we could bring a B from the right. Maybe this is the right. So yeah, maybe we can bring a B from the right, that is somewhere here. We can bring it here. That also we can do. So we have to choose one of these things, and a B can be pulled in from the right only if we have a A here, because only AB can be converted into B. So maybe we have like a lot of A's here. Okay, and what we will do is we will pick the first B and we will pull it in here, right? Something like that. And then yeah, so that's pretty much it. So that's how we will match B, and we will, I guess, adjust the A's accordingly. Okay, and then what we will do next, yeah, so what if we have a C here? So again, if there's already a C here, then that's just fine. Otherwise we need to pull a C from the right, and then all of these have to be B, because if there's any A here, then it's not possible to do. So yeah, so that way we will pull a C from the right to this position, and then all of these will get shifted. Okay, so I guess that's it. we just need to like store the next position of C, I guess, and then the next position of B and everything. But one more thing is there. It's that if we pull a C and then yeah, we can pull many C's, and then the B's should be there. Okay, yeah, we can try, but then uh, there might be some problems with how we will, maintain the correct indices of everything. But yeah, we can definitely try. What's Q? The number of test cases. Okay, we have the number of test cases, and then in each test case, we have an integer n. Okay, and then we have two strings s and t. Okay, so when we get all of these three things, what we want to do is we want to match the characters of s like that. So for that, I guess what we can do is we can keep mm, I guess we can just keep three Qs for A's, B's, and C's because we only care about the first occurrence of each of these characters. So we can just keep three Qs. Okay. And then I will just populate them. Okay. Q of Si minus A dot push the I. Okay. So these Qs are containing the smallest indices of everything. And yeah, so we just care about the first position, like the first occurrence, the next occurrence of that character. And yeah, that's it. So now we can just, I guess, iterate on T one by one like this. Okay, and the only thing that we need to make sure is that there's no uh, like if we try to pull a C from here, so all we have to make sure is that there shouldn't be any A in between this C and this current position, right? So we have the character C, okay, and okay, if this is A, right? This is pretty straightforward, I guess. What we want right now is we want okay. So if the q1 dot front, that is the like the nearest B, okay, so if that is like nearer than q0 dot front, or if q2 dot front is nearer than q0 dot front, okay, so that means A is not the nearest thing. The nearest A is not the nearest thing compared to the nearest B or nearest C. So then we can just say that the answer is no, and we can return from here. Okay, I guess that's it. Otherwise, just q0 dot pop because we have used up an A. Else uh, if like C equals B, so what will happen if C is equal to B? Okay, so then what we want to do is we want to pull a B and we don't want any A in between. No, we don't want any C in between actually. So if q2 dot front is actually smaller than q1 dot front, that means the nearest B is actually farther away from the nearest C. So we would have a CB and we cannot convert a CB into BC. Then again, the answer is no, and then we will return from here. Okay. You might be thinking, why am I not uh, considering the fact that when we pull a character from the right to the left, then the indices of like, for example, if I pull this from here till here, the indices of all these have to increase by 1. And I did have that in mind, but the fact is that we are only caring about the relative positions, and we don't need to know the exact positions, we just need to know whether it's greater or smaller. So I guess we don't have to care about that. At least that's what I think right now. So, like, if it doesn't work, then maybe we'll try to account for that as well. But I'm pretty confident that it would work. Okay, so what if, otherwise, obviously, this character will be C. So, if it's C, then what we want to do is pull, we want to pull a C from the right, or like we can have it right here. So, the only thing that we want is like BC is allowed, because BC we can just swap that and get CB. Just like it's given in the question, BC can be converted into CB, but we cannot convert um, AC into CA, right? So we don't want a in between. So the nearest C should not be farther away from the nearest A, right? So if Q0 dot front is actually smaller than Q2 dot front, that means the nearest A is actually closer than the nearest C. So then again the answer is no. Okay. And we will return. Otherwise, we have used another. Okay, sorry. Otherwise, we have used another C. So if we reach the end of this loop, that means we have used up our characters in a correct order, and then the answer must be yes. At least that's what I think. I think this should work, unless I'm missing something very obvious. But yeah. Okay. So I definitely am missing something obvious, because this is not what the answer is. So, okay, so it's wrong even for the first test case itself. How can it be wrong for the first test case? Okay, it's giving no for this. Okay, I can definitely see some of the mistakes that are there. But let me just debug this very quickly. I know some of the bugs. I can already see it. The queues can be empty, and I never accounted for that. But yeah, I guess that's the problem. Yeah, I guess that's the only problem. I never accounted for the fact that the queues might be empty, and I don't have to perform checks for that. I guess maybe I can just do q0 dot push n. Here n is basically just infinite, because n minus 1 is the last index, and for all of these I can do this, then it should be correct. Okay, seems to be correct till now. We have 4 yes and then 1 no. Okay, so again, now this second case is wrong, I guess. Oh, okay. Right. So, okay, I guess we can just check one more thing, that none of the queues should be empty, because we have to never use the last character that is infinite or something. So if q0 dot empty or q1 dot empty or q2 dot empty, if any of these are empty, we can just see out no and return. Okay, so this basically means that we use the, like, this is the non-existent character. Okay, and if we used up the non-existent character, then that means obviously it's wrong because we cannot use it. Okay, now it works. So this was more like a, I guess, like somehow we just managed to make this work. The correct thing would have been to perform some um, null checks, basically check if the queue is empty and then return no right here, something like that. And we are getting wrong answer as well. So let's just forget this and this. Okay, and let's do that only. So if we want a, so if we want a, so what we want to do is we want to make sure that q0 is not empty. So if q0 is empty, then definitely it's a no. Here if q1 is empty, then it's a no. Okay, and then here if q2 is empty, then it's a no. Okay, again I'm getting no. No, that's weird. Okay, let's do this. Okay, maybe we have to do some more null checks. Okay, that's that. So this is valid only if q1 is not empty. So if q1 is not empty and its front is actually smaller than q0 dot front, and again here, okay, so if q2 is not empty, okay, cool, right? Similarly here, this is valid only if q2 is not empty, and this is valid only if q0 is not empty. Okay, okay, let's try it again. Fine, okay, we should have done it in the first place. Now this is very messy, so how to do like a clean thing for this one? And I think the correct thing here to do is uh, we can just make a function here. Okay, and we can manage all that within this function. Okay, so this is basically right, something like check 1 comma 0 or check 2 comma 0. Okay, and what this function will do is wait a second, I'll implement this. Okay, so what this function will do is it will do this entire thing that's written in the bracket, so it's a little cleaner. So here it's check to 1. Okay, and this one's just check 0 2. Okay, and then we can actually include this within it, within this. Okay, or maybe just let's just keep it separately. We can include it, right? Yeah. So in check xy, the first thing we have to do is if qy dot empty. Okay, so if this is empty, then just return false, return true actually, because if this passes, then we have to print no. Okay. Next, if qx dot empty, then return false, and if both are not empty, then we can do this check. So if qx dot front is like smaller than qy dot front, then return true. Yeah, so we can make like a small function here, and then this whole part becomes a lot more easier. Okay, otherwise return false. Okay, so yeah, basically whatever conditions I had written inside this bracket, now I moved it to lambda function, and I'm just using that, so it's more clean. And yeah, so that's what I should have done in the first place. Okay, cool. Guess the string. Okay, we'll try. Oh, it's an interactive problem. That's nice. So we may use std flush something something, and okay, that's just interactive guidelines. I guess we have to guess a string of size n. Okay, and we may ask queries of two types. One is, okay, so in one character, in one query we can just get a character from the string, and that's nice. And in the second query, what we can do is we can get the number of different characters in the range si to sl to sr. Okay, and strategically they have given the first query cannot be like first character, you can only ask up to 26 queries of the first type and not more than that. So I guess there's some significance to that, and obviously there is. What what I guess we have to do is we have to, I guess, like, because we can only have 26 different characters in the alphabet, we have to do something with that probably. And then the second query basically tells us the number of different characters in in a certain range. So maybe we have to use that somehow. Okay, I mean, obviously we have to use that somehow to get the information about each character. Okay, so first of all, I guess we need to know what the first character is. Okay, so without loss of generality, let's say it's X or something. Okay, the first character is X, and then what we can do is we can try to see how many more X's do we have here. So let's just check how many distinct characters are here, how many distinct characters are here, and so on. So this way we can find the total number of continuous X's that we have, and it might be just one. But after that, when we finally get two, that means there's some other character here. So we don't know which character here is, but we have like a sequence of X's and then a hidden character. So next thing what we can do is we can just check what this character is, and let's say if it is Y. Sorry. Okay, so maybe we can next check how many Y's do we have here. Okay, or let's just say I want to see what this character is. So first I will do a query on this, and if I get the value 1, that is if only one unique character is there, one different character is there in this range, so obviously it has to be y. But then if that doesn't work, then I will do a query on this range, and then if I get 2, that means here we have x. But if I get 3, so if I get 3, that means this is a totally new character. In fact, yeah, so if I get 3, then obviously this is a totally new character, and I have to like I can do a new query to get this new character, and this might be like a z, or otherwise it can be x or y. So it can have like a sequence of x's and y's uh, like this, and maybe we just need to store the position of the last x and the last y and so on. Okay, because now if I want to get what this position is, uh, I can check if this is x by doing this query. I can check if this is y by doing this query. And here if I get like a 3, so obviously this is a new character, and let's say that is z. So again I can do check for this character. It could be this, or it could be this, or it could be this. And if I'm getting like a 4 here, so obviously this is a new character, and I can ask the first type of query to get the exact value of this character. It could be a or something. So in this way, obviously we can get uh, other 26 different characters. Each character is a lowercase Latin letter, so that also works. Now there is just one problem, I guess, and that's that what if we had a string such that in the beginning they had all the a b c d e f g till z. Okay, so first we will guess all this, and then maybe in the next for the next whatever, around 1000 characters, we might have to run 26 queries each. And I guess that's the problem, because if we're doing like 26 queries each, so um I guess the problem is basically that we might have to use 26 multiplied by 1000, that is 26,000 queries in total, but we just have to use 6,000 queries. So there I guess we can do like a binary search, because we have these 26 characters, and this new character is one of these. And then what we can do is, instead of checking one by one if it's z, if it's y, if it's x, if it's e, d, c, and so on, we can just do a binary search and we can get it more quickly. So a binary search on 26 elements would be like log of 26, maybe 5 or 6, and yeah, that would be fast enough probably. So how can we do that? Okay, so if I run a query on this range, okay, and this contains, let's say, 23 characters, right? This contains 23 characters, and if the total number of different characters in this range is just 23, so that means the answer could be either D or somewhere to the right. But if it's more than 23, if it's like 24 or something, then the answer has to be on the left, because like it has to be either one of these characters or maybe an entirely new character. So yeah, I guess that's what we have to do in this problem. Just when you find a new character, do a binary search to see which character it is out of the known characters, and then if it's like none of those, then yeah, if it's none of those, then just ask this character, and that won't happen more than 26 times. So that's it. Okay, let's implement this then. Right, so the first thing is we need the n, that is the length of the string. Okay, and we can make like two functions for queries. Okay, that's how I will return the character, and then I can make another query. Sorry if you can hear those drums, because I guess it's somebody's wedding. I'm in this five-star hotel where there are a lot of weddings now and then. Just flexing. Okay. Um, right. And we just read the input. It's more convenient to have these functions for queries, and then we can just make a function for answer as well. Okay, cool. So now we can have like a string s, and I will make this character by character. So let's first get the first character of this. Okay. So s dot push back query z, or query 1 actually, right? S dot push back query 1, and that will give me the first character. Okay. I actually want to use zero based indexing, so I'll just do I plus plus here and L plus plus R plus plus here, so that I can use zero based indexing. So first I guess the first character, and I just put it in my string. Okay. And once I do that, I will do something else. Okay. Anyway, so I go to the first character up till the last character. I mean the second character up to the last character. The index is 1. Okay. Now I'll try to guess which character this is using a binary search. So I need to have all the characters that are there. Okay. So I just need to store the indices of the characters that are like relevant, right? Yeah. So I can maybe just keep a set of those. Okay. And obviously 0 is relevant because okay. And since I want to do a binary search, I want constant time accesses, so I'll just copy it into a vector. Let's call it v. This works, right? Yes, it works. Yeah, it will copy the set into the vector. Right now from this vector, and I know which character is there at which position because I have this string. Okay. Now from this vector, I want to perform a binary search, and I want to get yeah, so int l equals 0, u equals size v minus 1. Okay. And int answer equals -1. Okay. Then I'll perform a binary search. So before I even write this binary search, I need to properly understand what I'm doing inside this. So in this binary search, what I'm trying to store is I'm trying to store in the answer what's the character that works basically. So if none of the characters work, then that's why my answer would be -1. So if answer equals -1, that means no character worked. And now I want to get the actual value of this character and push it in the string. Okay. And then once I do it, this new thing becomes relevant. I becomes relevant. Okay. And the yeah, okay, obviously the I becomes relevant, that's it. But otherwise, if answer is not equal to 1, so then that means we found a position in the vector v such that this current character is equal to that character. So basically s of I equals, or s dot pushback, obviously s dot pushback, that character s of v answer, okay, because that's the index. This is the index in this vector that we that this character is same as. So I push it in here like this, and then this has to be removed from the relevant set. This index has to be removed from the relevant set because now this is not relevant anymore, because now instead of that I is relevant. Okay, so I'll just put it here because in both cases I becomes relevant. So I guess that's it, and now I just have to write the binary search. So in this binary search, what I want to do is I want to check if like m, or if if you have to go left or right, basically, right? So if vm, okay, vm is the index of that, okay, I'm only storing the last occurrences of everything. So if query of vm comma I, which is the correct position, okay, so and this is storing the number of distinct characters in this range, okay. Now if this is equal to uh, if this is equal to the number of characters in that range, basically, which would be um like let me just see, if m is like the size minus 1, so then it has to be 1. If this is size b minus m, because basically what I'm trying to say is, let's say this is the vector v, and if I'm working with this one, and up till this index I'm talking about, so this I want it to be 2, and then this is the like 0 1 2 3 4, and the size is 5. 5 minus 3 is 2. So if this is equal to this, that means answer might be equal to m, okay, but we want to go to the right, we want to go more towards the right, l equals m plus 1, but otherwise u equals m minus 1. And I guess that's how we will be able to guess the string, and we can just answer that string, whatever we get at the end. Okay, so let's say our string is guess, like they've given. I'll just input like 5, okay, and it's asking what's the character at the first position, that is obviously g, and then it's asking how many distinct characters are there in 1 and 2, so that's 2, and then they're asking what's the second character, so that's u. Then they're asking what's the number of distinct characters in the range 1 to 3, so again that's, I guess that's 3, right? And then they're asking what's the third character, that's an e. Number of distinct characters in the range 2 to 4, so in the range 2 to 4, 2 3 4 3, in 1 to 4, that's 4, okay. Then they're asking the fourth character, so obviously that's s. In the range 2 to 5, there are 3 distinct. In 3 to 5, 2 distinct. In 4 to 5, there's only 1 distinct. And okay, I don't know if you can see this, so yeah, yes, I got the right answer, right? My camera must have been blocking that. Let me put this back in here. Okay, yeah, you can see. I guessed the right thing. So I guess this is correct, and I can just submit this now. Okay. I mean, there might be some implementation error, but the idea is definitely right. Oh, wow. Wrong answer in test one. Incorrect query format. Mm-hmm. Did I forget the exclamation mark? I didn't. Mm-hmm. Mm-hmm. Why was this wrong? Oh, I forgot the question marks. Okay, that was very silly. Yeah, I forgot the question marks. I just saw this and didn't notice that we have to put the question marks. Okay. That's what happens when you are out of practice. But anyway, wasted a few seconds there.